All right, so I'm just going to show you uh, what I thought was a good example of how to do the test. There's a number of people that did the test this way. And first, let's start up here at the top of your test. I think it's in black for each one of my classes that the score on the left, I think, in black, is the test score here. And then this one, the blue one, is the one on Pearson. Could be reverse of that. So, check Pearson, make sure I'm telling you the truth there. One of the two numbers is Pearson, one is the score on the test. But you can see this person missed no points on the test. And it's a 6-point rubric. So a 6 means it's a perfect score. I can't find anything wrong with it. If there was some small mistake, like some people didn't put parentheses right here. Check it out. See how there's parentheses right here? That's important where the parentheses are. Right here, the parentheses. If you didn't do that, it doesn't really square out to be a positive y. Or over here, it doesn't square out to be a positive x squared, right? You have to have parentheses around that for it to square. Or some people put the negative in front of the 3. So a small mistake like that would be a 5 out of 6, all right, if you didn't have the parentheses. If it's a larger mistake, like you're showing the wrong symmetry, or you're doing all this work, but it's just the wrong point that you're putting in, then it might be a 4, which is a 75%. So a 5 out of 6 is a 90% on my rubric. A 4 out of 6 is a 75%. If it's a larger mistake, like, yeah, you're trying to do some algebra here, but it doesn't seem like you're plugging it, really kind of the right information in for x and y, then it would be a 3, which is a 60%. And then if it's like kind of, man, I'm not sure you know what you're doing there, or maybe you just showed me a picture of symmetry, like you know what symmetry is, but you're not doing this algebraic proof of it, then it would be a 2 out of 6, which is a 40%. And then if you have something down, like anything, it might have a 1 right here, and that'd be a 20% on this particular problem. So if you follow along here, this is what a perfect paper looks like. Let me get rid of my little red marks here. Well done here. And then on the next one, we're taking the point 6.5 and 8. They found halfway between 1/8 and 12/8. Well, the y value is still going to be 8, right? And if you add 1 to 12 and divide by 2, that's how you find the midpoint, right? So 1 plus 12 is 13, divided by 2 is 6.5. A lot of you guys did great with that. You found the radius is 5.5, like the distance from 6.5 to 12 is 5.5. You can subtract the two numbers, right? 12 minus 6.5, or 6.5 minus 1 gives you the radius. And then the radius squared goes over here on the right side of the equation, and then the x value goes after the x value of the center, so we go x minus 6.5, and the y value goes after the y, so it's y minus 8, right? And then you have them squared, of course. That's the standard form of a circle, because it's really the distance formula, the distance from this point to any point on the circle, x comma y. Like if we put a point right on the circle, and we said, okay, here's our point on the circle, and we called that x comma y right there, the distance from x comma y and 6.58 is 5.5. Well, it's leg squared plus leg squared equals hypotenuse squared, right? So like if this point was x comma y, we're going to go over some amount, up some amount, and that distance that we're going over is right there. The distance we're going up is right there. And then the hypotenuse squared, so 5.5 squared, is on the right side of the equation. I hope I made that clear, that standard form is just really the Pythagorean theorem. And then right down here, we're completing the square. So this person took half the -6, squared it. That's where the 9 comes from. They took half of the -8 and squared it. That's where the 16 comes from. So like half of -8 is -4. -4 squared is positive 16, right? So what are we adding to the left side of the equation? A 9 and a 16. Look how they put it on the other side too, to keep it the same equation, right? And then, they kind of factor this by grouping. Well, I didn't notice that when I first checked their work. You don't have to do factor by grouping here, because we have a perfect square. And the pattern for a perfect square is you take the square root of the first term, boop, right there, and you take the square root of this, the last term, the 9, right here, the 9, and that goes right there. and you could take the same sign that's on the middle term, or you could take just half of the middle term. See how there's a -6 there? Half of -6 is -3. But that only works if you have a perfect square trinomial. So it requires that you have that confidence that it definitely is a perfect square trinomial. I guess they're kind of showing that work right down here, but you didn't need to factor by grouping. You could have just skipped right to that step right there and skip right to that step right there. Okay, so here's their standard form equation. To find the intercepts, they're plugging 0 in for y. Oh, this is beautiful work. This is how you find the x-intercept, right? So you notice they're plugging 0 in for y right there, right there. You can see it in their ordered pairs, and then here are their x components for the intercepts. And then to do the y-intercepts, we plug 0 in for x. It's beautiful work. Well done. This is what the test I was hoping would look like. And thanks for watching my video. Appreciate it.